Welcome to the Dwarfguard showcase video. Dwarfguard is a software to guard your devices, focusing on industrial cellular routers and Linux devices. In this video, we will go through example usage, showing some of the features. If you are interested in details, follow to the specific video guides. Manually adding one device is easy. Download the agent, open device web pages, install as any other router app. Looking into device details on the server, you can see the actual reported data and also historic data for some selected metrics. Let's review supported device types. Next to the Advantage cellular routers, Dwarfguard supports Teltonika cellular routers, OpenVRT devices, and provides generic Linux client able to run on virtually any Linux distribution. For mass deployment on many devices, there is the automatic agent deployment tool. The most versatile organization technique is using monitoring groups. Let's create first a monitoring group for our routing infrastructure, calling it Backbone. Once created, we assign the routers into the group. Next to the Advantage routers, there is also a Linux file server part of the Backbone. Each and every monitoring group is shown on the dashboard. You may notice the All Devices System Monitoring group that encompasses all of your devices all the time. The monitoring group lights breakdown offers a shortcut for quick navigation to subset of devices in that particular state. Devices in the Backbone group are quite important to us. By assigning a different agent profile to these devices, they will send data more frequently, starting with their next contact with the server. The layout of the devices table is customizable. Let's go to System, Settings, and add the Agent Profile column. By filtering the devices so that only those being part of the Backbone monitoring group are shown, we can verify that the agent profile has been assigned. Next, we create monitoring group for the devices installed in our trucks. Once the group is created and devices assigned, we will also switch all the devices to the slowest agent profile. The trucks may be offline for a number of days, so there is no point in getting alerted in this case. You may edit the agent profile time values in Agent Profiles. Remember, the device always reports data after boot, which plays quite well with devices that are not being up all the time. The last group we create is for our computing cluster. After creating the group, we assign all the Linux devices but the file server into that group. Let's create a custom alert for the cluster. Go to Alert and start defining it. The alert name is used in the email and Slack notifications, so it is good to pick something accurate. Dwarfguard supports two alert types: alert for a single device and alert for a group. We will define alert for a group. Pick the cluster monitoring group. Our cluster consists of 5 nodes. Let's say that once 4 or more nodes are under load, we would like to get alerted. The suitable metrics to use could be the average load for 15 minutes. The load value to be checked depends on your preference. Remember, you can edit the alert at any later time if you find out the definition is imperfect to your needs. The server will pick the new alert definition in a few seconds. Once that happens, the alert gets listed on the monitoring group entry on the dashboard. Looking into alerts, you may notice there are some factory-defined alerts. You may disable, edit, or remove these as you wish. Let's also prepare more strict alerts for the backbone monitoring group. First, guarding the device temperature, specifying a lower temperature than the one being checked for all devices. Second alert will trigger anytime the backbone device misses a single data push. The global light icon at the top that always indicates the global system state is auto-reloaded and serves also as a shortcut to the dashboard. Once at the dashboard, we see there is a problem with one group. Locating the group indicates there is a raised alert. All raised and passed alerts are listed below the group breakdown, including a listing of a few devices for which the alert is raised, and also a shortcut to the table listing all of them. Following to the device details, we see that the actual data shows 0 missed contacts. The device was probably delayed by only several seconds. Our alert definition is very strict, and the alert will lower on next alert evaluation that happens every 30 seconds. For the sake of the demonstration, let's suppose we really suspect a problem with the device. We set up a web tunnel, which is a tunnel initiated from the device side to the server, allowing us to log into device local web interface through the Dwarfguard server. Note that the unique tunnel link does not require login into the Dwarfguard server itself, allowing you to pass the link together with the device web logon credentials to a third party if you want, for example, to allow support company to access the device. But what if the alert lowers before we have a chance to look into the system? The answer is that it will count as a passed alert. Regardless there is a notification sent out or not, no alert being raised is discarded. You can review the past alerts on the dashboard, listing all the affected devices. Once you possibly take an action and acknowledge the alert by clearing the counter of alert detections, the system returns to all green state. Sometimes, just the device details are enough to help you. In this example, the device is too hot, and just by scrolling down to the history statistics, you can see the device availability is not 100%. Also, there is a nice tool that can help you to find out extremes among your devices. If you visit the changes tracker, you may, for example, select a metric and quickly find out the device reporting, e.g., most reboots. Optionally, you may also filter the date to a specific time frame. Now, let's say you have a device that misbehaves frequently and you are sick of constantly reviewing alerts for this device. The router manufacturer is telling you it will be fixed in the new firmware. A simple technique to remember that this device is to be flashed later when the firmware becomes available is to create a label. You can use the label later on the devices table to filter out only these devices with the label assigned. When there is a new firmware produced, go to the Software Manager, Firmware, and add the new firmware version there. Once Dwarfguard downloads the firmware, and the particular firmware version is approved by you, you can assign it to the supported device types. Go to Device Details, pick the desired firmware version, and confirm. The device status will switch to pending state, and once device comes with the next data push, it will pick the firmware flash command and perform the operation. Looking at the agent logs on the device, you can see a log entry regarding the new firmware flash operation. After the reboot, the device reports the new firmware version to the server and will return to the synced state. Note that you can also perform mass firmware assignment operation on the devices table. Our brief walkthrough over some of the features is over. What didn't fit? Want to run software as a service or on-premise? Both are supported. Have many devices? Look at the performance testing results. Dwarfguard is able to handle tens of thousands of devices. To try out the software as a service, you can ask for a demo being set up for you using the mentioned URL. Another point worth mentioning is that the Dwarfguard is an actively developed product, and there is also a possibility for custom development. If you want to try the product out in your own environment, you can download the free version and deploy the software on your own server with no strings attached. Thanks for watching! To watch other Dwarfguard videos or find related information, follow the displayed links.